Bismillahirrahmanirrahim. I am Mr. Sanaul Nahan, lecturer in Computer Science, Institute of Computing, Kohart, University of Science and Technology, Kohart. So, I am the course instructor of Computer Graphics, CS443. Today I want to deliver lecture number 9. The topic is Circle Drawing Algorithm. This is the outlines, objectives, circle, what is circle, simple circle drawing algorithm, 8-way symmetry, midpoint circle drawing algorithm, example, and some tasks. So what is the objective of the today topic is to discuss the basic concept of circle drawing algorithm, to understand the mathematical and algorithmic concept of circle drawing algorithm, to utilize an OpenGL programming for circle drawings. So what is meant by circle? It can be defined as a set of points that are all at a given distance r mean radius from a center position means xc, yc, which is also called origin. Twice the radius is known as also diameter. The angle a circle subtends from its center to is a full angle which is equal to 360 or 2 pi radians. So this is the circle. This is the points which is having same distance or equidistant to the center from each and every side. This is the octant, this is the octant, this is 4 octants. So the circle has the maximum possible area for a given perimeter and the minimum possible perimeter for a given area. The perimeter C of circle is called the circumference, and mathematically it can be written as C is equal to 2 pi. So simple circle drawing algorithm, which is simple equation for the circle, is x square plus y square is equal to r square, where r is the radius of the circle. So we can write a simple circle drawing algorithm to find out the y coordinates using this equation when x is increased with a unit interval. So by taking a square root, we can find y is equal to plus minus r square minus x square. So using this equation, if we want to put some values, then the circle will be drawn, the pixel will be drawn like this. Let's suppose y0, we have in r square radius, where a radius is equal to 20 and minus x initial value origin, which is 0. So 20 square minus 0 approximately it equal to 20. Same is the case for y1, same is the case for y2 up to y20. Then the circle will be drawn like this, but again some pixel are missing. This is the problem, that which one pixel will be selected, a top one or bottom one pixel. So however, unsurprisingly, this is not a brilliant solution. First problem is that the resulting circle has a large gaps where the slope approaches the vertical. Second problem is that the calculations are not very efficient. The square root, square multiply operations, the square root operation, try really hard to avoid this. It will create a computational problem. It become a computational expensive. So we need that type of algorithm which is more efficient and provide a more accurate solutions. So 8-way symmetry, which is one concept used in circle. The first thing we notice to make our circle drawing algorithm more efficient is that circle centered, which is 0 and both are 0 in x and y, both equal to 0, have 8-way symmetry. We use the above algorithm to calculate all the perimeter points of the circle in the first octant and then copy these first octant perimeter and mirror these points to the other three octants. This will work only because circle is symmetric about its center. So this is the symmetry. This is the first octant. This one point is symmetric to this one. So again, this one point is also symmetric to this one. This one point is symmetric to this one, and so on. So if we want to find the first octant symmetry pair points, then it will be reprint to the and mirror to the another octant points as well. So if we find out here this point, then same this point will be reutilized or reprint here in this points. So midpoint circle algorithm, similarly to case with lines, there is an incremental algorithm for drawing circle. Means if one is increased with y, x is increased in unit interval, then what will be happen with y? So we use 8-way symmetry. So only ever calculate the points for the top right edge of a circle and then use symmetry to get the rest of the point. So if assume that this is the point xk and yk, I consider that is the origin. So from here there are 2 points also which is xk plus 1 yk and xk plus 1 yk minus 1. Now assume that we have just plotted point xk and yk. The next point is choice between xk. This is our choice, that how we can select xk plus 1 yk or xk plus 1 yk minus 1. So we would like to choose the point which is nearest to the actual circle. This is the actual circle. How we can choose this point which is nearest to this circle. So how do we make this choice? That how can we find that this point is nearest to the circle? This is the main problem. So let's rechange the equation of the circle slightly to give us let's suppose f circle xy, function of xy. So x square plus y square minus r square, this is the actual equation. So the equation evaluate is f of circle xy less than 0, then it means that fx is inside the circle boundary, then it is inside, the point is inside the circle. If x is greater than 0, the point is outside of the circle. If it is equal to 0, means it is only on the boundary of the circle. So we evaluating these functions at the midpoint between the candidate pixel, we can make our decision about due to this formula we can make decision that which pixel or which points will be selected. Like this scenario, this is on the boundary, means it is equal to 0. When it is greater than out of the boundary, and it is less than inside the boundary. So assume we have just plotted the pixel xk yk, so we need to choose between xk plus 1 yk and xk plus 1 yk minus 1, which one to be choose. So our decision variable can be defined as midpoint between 2 points. First one is xk plus 1 yk and the second one is k plus 1 yk minus 1. So after this process in this combinations, xk plus 1 yk minus 1 over 2, because it is the midpoint, we can divide by 2. So pk decision parameter will be equal to xk plus 1 yk minus 1 over 2. After calculation x square plus y square minus r square. So x put the value xk plus 1 square plus yk minus 1 over 2 whole square minus r square. So here the condition is if pk is less than 0, the midpoint is inside the circle and the pixel at yk is closer to the circle. Otherwise the midpoint is outside and yk minus 1 is closer. Because we want to find out which point is closer to the circle, the real circle, then it will be selected. Now this point will be chosen using the decision parameter which is pk. If the value of pk is less than 0, that it means that the midpoint of the circle is inside the circle which is closer, otherwise it is larger. So this is the complete procedure of this algorithm. First of all, we input r and circle center. It will be given the set of coordinate for the first point and the circumferences of circle centered, and the origin is xc yc, means x0 yc, which is equal to first time is r. So calculate the initial value for the decision parameter. Decision parameter is given p0 is equal to 5 by 4 minus r. If r is an integer, then p0 can be rounded to p0 is equal to 1 minus r. If the p0 value, decision parameter value equal to integer value, means 3, 4, 5 and so on, then it will be selected 1 minus r. If it is not integer value, means 3.5, 2.5, 3.8 and so on, then we will select 5 by 4 minus r. So at each xk position, starting with k is equal to 0, 1, 2, 3 up to so on, if pk is less than, the next point along the circle centered is xk plus 1 yk, and for the next coming points pk plus 1 will be given mathematically pk plus pk previous value plus 2k xk plus 1 plus 1. If the condition is in reverse, means pk value is greater than or equal than the next point, so along the circle is, then we can select xk plus 1, the bottom points yk minus 1, and pk plus 1 will be changed, pk plus 2 xk plus 1 minus 2 yk plus 1. So where 2xk plus 1 is equal to 2xk plus 2, while 2yk plus 1 is equal to 2yk minus 2. So identify the symmetry point and other 7 octant. So move xy according to x plus xc, y plus c, and so on. This is repeat step 3 until x is greater than or equal to y, or it becomes same, means on same points or x is greater than or equal to y. So this is the basic step of algorithm. Now coming toward the examples. So to see the map point circle algorithm in action, let's use it to draw a circle centered at 0 0 with the radius of 10. Okay, so their radius become 10, then it we combine, then it will become 20, both sides of radius. So determine the position along the circle octant is first quadrant. So x is equal to 0 to x is equal to y, up to from 0 to start up to y. So the initial value of the decision parameter is 1 minus r, because radius is equal to integer value which is 10. So 1 minus r, 1 minus 10 is equal to minus 0. So minus 0 is less than 0, not greater than 0, mean negative values. So for circle centered on the coordinate original, the initial point is x0, y0, which is 0 and 10. So the initial increment term for the calculating the decision parameter are 2x naught is equal to 0 and 2y naught is equal to 20, because multiplied by 2. So this is the decision parameter which is given. If the value is less than 0, decision parameter is this 1 minus r. If it is less than 0, then it will be increased like this. So x will be increased with a unit interval and y will be remain the same. So initial value of the x is 0, and then it become the initial value of the y is 10. So k is equal to 0 for initial, and p0 which is minus 10. So pk is less than 1. So x will be increased xk plus 1 and y will be remain the same, like this here is given in the algorithm. X will be increased with 1 and y will be remain the same, means no change in y. So here pk is less than 0, x will be increased, x value, first initial value of x is equal to 0, so it will become 1, and the y initial value is 10, it will be remain the same. After that pk plus 1 for another points will be increased. So pk plus 2xk plus 1 plus 1. So put the value pk means p initial value 0, 0 plus 1 p1 is equal to p0 previous value plus 2 xk plus 1 is equal to minus p0 is equal to minus 9 plus 2 into 2 xk plus 1, 2 xk plus 1 is equal to 1, 2 into 1 plus 1 which is again is equal to minus x. So it is again less than 0. So x will be increased with the unit interval and y will remain the same. So x will become 1, 2 and y will be the remain same 10. So after that pk plus 1 again. So pk plus 1 it will become 1 plus 1 p2. It is become previous value p1 plus 2 into 2 plus 1, again it become minus 1 less than 0. X will be increased with unit interval and y will be remain the same. So for the third condition, now it is 6 which is not less than 0, which is greater than 0. So the condition also become changed. Here x will be increased with the unit interval, while the y will decrease with unit interval, not remain same. Here check the condition in the algorithm. So if it is greater than 1, then what will be happen? Xk plus 1 will be increased, x will be increased with unit interval and y will be decreased with a unit interval. So it will become that 3 unit interval, x will be increased with unit interval 4, it will be decreased with unit interval, it become 9 again for k4. So for last again it is less than minus 3 less than 0. So it is increased with the unit interval, it remain the same up to last one using this procedure. So finally the table has come. So case 0, 1, 2, 3 and 4 pk values xk plus 1, yk plus 1, 2xk plus 1, it is again same value. Then we can plot like this. So as second example, given a circle with the radius is equal to 15, demonstrate the midpoint circle along by the determining position along the circle x is equal to 0 to x is equal to 1. So p01 minus r, because radius are also in integer, so we use this formula minus 4, plot the initial point which is 0 x and y will be 15. So 2x will be 0 and 2y which is used furtherly 30. So successful decision parameter value and position along the circle path are calculating using the midpoint is, after calculation midpoint this table is coming, and then after that we will draw these points on the screen. So use the midpoint circle using this algorithm. Finally first octant, then it will be increased up to other octants as well. So task 1, given a circle with the radius r is equal to 12, demonstrate the midpoint circle algorithm by determining position along the circle octant in the first quadrant from x to x is equal to 0 to x is equal to y. Thanks.